Hello, Professor. This is Matt Keene. I'm going to show you the operational capability of the Capstone project that I created. This is a software-defined radio capstone showing a issue with this GMRS radio. I'm going to show a capability to do a replay attack on it, and the tools that I used to be able to do this replay attack were created using the Odroid U2 right here. And this software-defined radio called the HackRF, which has been connected to that. We see that on the big screen right here. And I developed the SDR service used for this. I ported over everything needed to be able to talk to the libHackRF. I ported that over from Linux to Android. And I also developed the simple activity to show a proof of concept capability to be able to do this. So, if we click in the applications area, we see that there is a SDR app capability. We click on it, and it comes up with multiple different buttons: a receive signal, transmit signal, so this is about the software-defined radio, query the SDR to see if we have any information from it or if we can connect to it, unbind from the service, which is running in the background talking through the native interface back to the software-defined radio, and kill the actual service itself without unbinding to it. So the first thing we'll do is query the SDR. In the bottom you can see that there was a query success, which means we are connected to the SDR at this point. We'll next receive signal, and I'll talk into this guy. So this is a GMRS radio running at around 400 megahertz. It is FM, narrowband, unencrypted data. That is used, it's like family radio service. It's basically a walkie-talkie that you can use in a 2-mile radius. So I will hit the receive signal on here, and then the HackRF will start listening in to that frequency and recording that data to the SD card. Test, 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 test. So, as you see, when we hit the receive signal, that sent the data to the SDR service to listen in on that specific frequency. A text message was shown showing that the device was in use and that you weren't able to actually retask it for anything. You'll also notice that the buttons here, receive signal, transmit signal, and query SDR, all grayed out and made it so you couldn't actually retask the device as it was actually receiving signal. Also, in the bottom here, the SD service itself sends out notifications showing when it's been tasked and when it's busy, and also when it finishes. So the next step, I'll hit the transmit signal, and what we'll see is the audio that I just did replayed back out onto this device. So what this has proven is that this device has no authentication on it, and that it is vulnerable to replay attacks from anyone. Some of the other capabilities of this device is to send out a GPS coordinate of where you are. It'd be very simple to spoof that GPS coordinate and show people in other areas. Again, what we saw was that when I hit the transmit signal, the buttons grayed out, and our SDR service showed that it was actually up and running and transmitting at the time. And then once it was finished, device finished came back up. So that is my capstone. It's been very fun. I learned a lot in a lot of different areas, from client-server communications, remote method invocation, working at the native interface, debugging at the native interface, developing very low-level operating stuff for the actual Odroid, and also creating a proof of concept from the information security standpoint of a replay attack. Thank you.